Hi everyone, today's question is from the topic thermal expansion. This particular question I have found that many students find it slightly confusing and some will just memorize the formula. So let me try to show you how that formula actually comes. So the question says a steel tape, by tape they mean a scale, measures the length of a copper rod as 90 centimeter when both are at 10 degrees Celsius. The calibration temperature for the tape. Now calibration temperature means that temperature at which the marking on the scale was done. When you make a scale, you have to do some markings, right? Millimeter, centimeter, isn't it? So those markings were done at some particular temperature. So that temperature is what is called calibration temperature for the scale. What would the tape read for the length of the rod when both are at 30 degrees Celsius? Given alpha for steel, by alpha they mean temperature coefficient of linear expansion, is given 1.2 into 10 power minus 5 per degree Celsius, and for copper the temperature coefficient of linear expansion alpha copper is given 1.7 into 10 power minus 5 per degree Celsius. Before solving the problem, let us quickly revise the concept of linear expansion and then we will relate. We will find the formula between measured length and actual length of a body. So at temperature T1, let us say the distance between 2 points is L naught. So L naught is the length of this part of the body. And when the temperature is increased, so T2 is greater than T1, I am assuming, the whole body will expand. So the distance between any 2 points will increase, right? So now the new length is L between A and B. So what will be this new length in terms of the original length? The formula is new length is equal to original length 1 plus alpha times change in temperature. So this delta T is nothing but final minus initial temperature. This alpha is what we call temperature coefficient of linear expansion. So let's say we have this rod whose actual length is this L actual, and we are using this scale to measure the length of the rod. I am assuming right now the temperature of the system is 30 degrees Celsius, and that is also the temperature at which calibration was done, meaning this is also the calibration temperature of the scale, the temperature at which the marking was done. So now let us assume this each division here is 1 centimeter. So what will be the length of the rod as measured by the scale? The measured length will be equals to 1 centimeter, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 centimeter. And that also will be the actual length because we are using the scale at that temperature, which is also the calibration temperature. Meaning this 1 centimeter is the true 1 centimeter, the actual 1 centimeter. Okay. Now let us measure the length of the same rod at 30 degrees Celsius. But this time we are using a scale whose calibration temperature is 10 degrees Celsius. Meaning at 10 degrees Celsius the marking on the scale was done. So at that temperature whatever 1 centimeter it will show, that will be the actual 1 centimeter, the true 1 centimeter. But now because we know because of the increase in temperature the scale will expand. So now this much will be your 1 centimeter, much bigger than the actual 1 centimeter, right? So now when you measure the length of the rod with this scale, how much will you find it? Well, it will be equal to, you can see from here to here is 1, 2, 3, 4, 5, 5 centimeter, which means the measured length is less than the actual length. Right? Now how to find relation between this measured length and the actual length? Well, it's quite simple. If you see carefully, this 1 centimeter is not same as this 1 centimeter, right? This 1 centimeter is the actual 1 centimeter. So let us call this 1 centimeter dash. So this should have been 5 centimeter dash. Now how do we relate the actual length of the rod with the measured length of the rod? Well, very simple. If you look carefully, this centimeter dash should be converted to 2 centimeter. That's it. Then we'll get the answer. Meaning this is actually 2 centimeter. Though the scale may be showing 1 centimeter, but actually it has expanded up to 2 centimeter, isn't it? So therefore, the actual length of the rod should be whatever is the measured length, which is 5, right? So this is your measured length 5, this is your actual length 10, and we just need to multiply with 2 centimeter. But 2 centimeter, remember, is the length of this part, right? Now, what was the length of this part actually at 10 degrees Celsius? Remember, 10 degrees Celsius is the calibration temperature. So at 10 degrees Celsius, this scale was showing the actual 1 centimeter. Yes or no? So when the temperature was 10 degrees Celsius, the scale was showing the true 1 centimeter. But at 30 degrees Celsius, it has expanded up to 1 centimeter dash, which is actually 2 centimeters. So this is like your original length and this is like your final length, isn't it? And what was the relation we wrote? L equals to L naught 1 plus alpha delta T. But alpha here is alpha of the scale, remember. Okay, we should use the alpha of the scale. And this L naught is the actual 1 centimeter at 10 degrees Celsius. So this is the actual 1 centimeter and this is the new 1 centimeter, which is actually 2 centimeter. That means here I should write L measured 1 centimeter into 1 plus alpha of scale into delta T. And what is this delta T? This delta T is the temperature at which we have done the measurement, T at which measurement was done, minus the temperature at which the markings were done, meaning the calibration temperature, which is Tc, right? So after understanding how the formula comes, you must memorize it, okay? So actual length of the rod is measured length of the rod 1 plus alpha of the scale, remember. So this S here I am using for scale, and delta T is the temperature difference between the temperature at which measurement is done minus temperature at which calibration was done, okay? For example, if the temperature at which you are doing measurement is same as the calibration temperature, meaning at 20 degree I did the marking and you are using the scale at 20 degree only, then there will be no issues, right? Because then delta T will be 0, and if delta T is 0, and therefore actual length will be same as measured length, isn't it? Let's come back to the original question. In the first part of the question they told a steel tape measures the length of this copper rod to be 90 centimeter. At what temperature? 10 degrees Celsius. So this is the temperature at which measurement was done. But that is also the calibration temperature of the scale. Therefore, in this particular case, the measured length is also the actual length, right? So the length of the copper rod at 10 degrees Celsius, let me mention here, is equal to 90 centimeter. Now, what they are doing, they are measuring the length of the same rod but at 30 degrees Celsius. Now two things will happen. First, the rod itself will expand and the scale will also expand, right? Because of expansion of the scale, the actual length and the measured length will not be same. So they are asking you to find the measured length, how much the scale will read. Now students, to find this measured length, first I need to find this actual length of the copper rod, the actual length. But the actual length is not this, remember, because this is at 10 degrees Celsius. Now the temperature is 30 degrees Celsius, right? So remember, this is the actual length. Let me put here comma actual. So how do we calculate this length first? Well, we will use the linear expansion formula. So length of the copper at 30 degrees Celsius should be length of the copper at 10 degrees Celsius 1 plus alpha of copper into delta T. And remember, this delta T is final temperature minus initial temperature, 30 degree minus 10 degree. So that would be the actual length of copper rod. right, at the temperature at which they are doing the measurement. Now they want you to calculate the measured length. I have already given you the formula between measured length and actual length, right? And that formula was this, right? Actual length is equals to measured length 1 plus alpha of scale, remember, and delta t. And delta t was temperature difference between the temperature at which measurement is done minus the temperature at which calibration was done, right? So now since I want measured length, that will be equal to actual length divided by 1 plus alpha of scale delta t. Now what was the actual length of this rod at 30 degree? That is this one, right? This is the actual length of the rod at 30 degree. So length of the copper rod at 10 degrees Celsius, 1 plus alpha of copper into delta t divided by 1 plus alpha of scale delta t. So now we have to just do substitution. So length of the copper rod at 10 degrees Celsius was 90 centimeter. Alpha for copper is given 1.7 into 10 power minus 5. The copper rod's change in temperature was from 10 degree to 30 degree, right? So the change will be 30 minus 10, that will be 20, divided by 1 plus alpha of steel was 1.2 into 10 power minus 5. And the measuring temperature, the temperature at which measurement was done was 30, and the calibration temperature was 10. So this also is 20, right? To save time, I have done the calculation for you. You can see 1.7 into 20, that will be 2 sevens are 14, 1 carry, 2 ones are 2, 3, right? So that will be 34, isn't it? Then 34, then this is 10 power minus 5, so that will be 0.00034, right? This will be 34 into 10 power minus 5, right? After 0.5 digits. Similarly, 1.2 into 20 will be 24 into 10 power minus 5. Now these two if you add, you will get this. Now you should have a feeling from here that this number is very close to this number, but slightly more. So the answer will be very close to 90, but slightly more. So 90.00, if you actually do it, you will get 90.0089. And then that can be approximated as 90.01 if you want to keep up to 2 decimal place, right?